All right, hey gang, we're going to be looking at this section 4.3 deals with parallel and perpendicular lines. Now, if I was to tell you this is the only time you will ever have to deal with parallel and perpendicular lines, then I would say delete this and move on, okay? But I'm going to guarantee you next year in algebra or geometry, and the year after that in algebra 2, you're going to have parallel and perpendicular lines. So if you learn it this year, you make your life a lot easier moving forward. So let's get right into this, and if you have questions, let me know as we get going here. First of all, let's make sure our terms are down. When we talk about parallel lines, a lot of people will give me pictures like this. They'll say, hey, parallel lines. They'll just use their hands. Oh, there you go. Parallel lines, right? Okay, which I'm fine with that, as long as we know that they can go like this too, and like that as well, okay? Perpendicular lines, a lot of people will do something like this, okay? Something like this, or the timeout symbol, okay, which is good. So you've got like a basis. Let's see if I can make that even better. There you go. You have a basis for which you can go ahead and make it know what the terms are. So in looking at that, let me go ahead and do this. Parallel lines never intersect, and I'll show you a picture. I'll just go ahead and draw something like this, and then like this, okay? Those would be considered parallel, okay? We're going to talk more about what makes them parallel, but for right now, that's all you need to know. Perpendicular lines, by definition, it would be two lines that intersect to form a right angle. So if I have a line like that, and then I form another line like this, they intersect to form a right angle right there, okay? So the difference between parallel and perpendicular, for all intents and purposes right now, is just that. Graph the following lines on the same graph. Make sure you extend the lines across the graph and make them straight. So I'm going to do y equals 1/3 x minus 5. Minus 5, 1, 2, 3, 4, 5. 1/3 x, up 1 over 3. 3, up 1 over 3. 1 over 3. 3. Down 1 over 3. Down 1 over 3. Down 1 over 3. Oop, 1, 2, 3. 3. There we go. So here's my line. Y equals, and I'll even write it right beside it. Actually, you know what? Since it says line A, boom, line A. Okay? 1/3 x minus 5. Okay? I don't know if that, maybe I'll do it more like that. Hopefully that makes sense. Okay, next one says 1/3 x plus 4. 1, 2, 3, 4. And I'm going to do 1/3. Up 1, 1, 2, 3. 3. 3. Go. This is line B, okay? Now, of the two types of lines that we've been discussing, what do you think those are? If you said parallel, ding, 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 we have a winner, Johnny. So, what's the difference here? Well, what I want you to see is this. The slopes of each of these are the same. So when we have parallel lines, we have the same slope and a different y-intercept. Now you might be thinking to yourself, why do we need to have a different y-intercept? Because if it's the same y-intercept, it's the same line, okay? And so as a result, parallel means the same slope and a different y-intercept. Now, for line C, we have a -3 slope with a y-intercept of 2. So I'm going to go up 2, and I'm going to do a -3 slope. Negative 1, 2, 3, positive 1. 1, 2, 3, positive 1. 1, 2, 3, positive 1. Go. Go ahead and graph this out. Now the question is this line C parallel with the other two? No, they intersect. So if we're talking about parallel and or perpendicular, it must be the perpendicular. I'm going to go ahead and show you that these have to be a right angle right here. So what are the characteristics with perpendicular lines? Perpendicular lines means this. We have what's called the opposite reciprocal. And if you want to use this symbol for reciprocal, you'll understand why in a moment, slopes. Okay? So, actually, I may have already just answered this down here. From your graph, which lines appear to be parallel? I'm going to say lines A and B. What do you notice about the slope of these lines? They are the same. So hopefully you got that from the first part right there. Which line appears to be perpendicular to A? Well, it would have to be C, line C. Do you notice something special about their slopes? So if I were to go ahead and put down slope and then perpendicular slope, okay, we're going to reemphasize what we were just talking about a moment ago. If the slope is 1/3, the perpendicular slope would be -3/1, okay? Opposite, because one's positive, one's negative, 1/3 and 3/1 means reciprocal. That's why I use this symbol right here, okay? So if I go into more detail, let's say I do -4/3 slope. Well, that would mean it would be a positive 3/4 slope, would be the perpendicular. I took the opposite of negative, made it positive. I took 4/3 and flipped it, make it 3/4, okay? If I was to do, let's see here, let's just go positive 1 slope. What's the opposite of that? That'd be -1. Reciprocal of 1 is also 1, okay? 1/1 becomes 1/1. All right, so again, you've got those opposite reciprocal slopes. So if you can memorize that, that will be beneficial for next year. We're going to graph these two lines, D and E, and we're going to determine the slopes, determine the rule of perpendicular lines. So if we go ahead and do this, this is another example. -5/3, positive 3/5, okay? Positive 4, 2, 3, 4, -5/3. Now remember, I can do this as like this, -5/3, or like this, okay? So I'll do it like the first one, -1, 2, 3, 4, 5, so positive 3. Okay, so this line right here is going to be line D. Line D, okay? Ooh, I'm getting off my page here, I'm sorry. Hopefully you saw me do that. Okay, so again, positive 4, and then -5, positive 3, -5, positive 3, okay? Positive 4 again, but I have 3/5 slope, so I can do, again, I can do 3/5 or -3, -5. -1, 2, 3, -1, 2, 3, 4, 5. I can go positive 3, 1, 2, 3, 4. I believe I'll be out in here somewhere. Let's see if it matches up. They're all collinear. I'm a little off there, aren't I? Should be down just a bit. Okay. And this is going to be line E. And again, you might want to go ahead and mark out that those would be perpendicular because we have the opposite reciprocal slopes. Okay. So hopefully that makes sense. Opposite reciprocal leads to perpendicular lines, okay? All right, now, the next part talks about, actually, I'll go back here like this. So here we go. Given that we have y equals 1/2 x plus 4, with your group, write an equation of a line f such that it's parallel to the given line. I'm actually going to go ahead and graph that line. Plus 4. 1, 2, 3, 4. -1/2 slope. So I can either do +1, -2, or I can do -1, +2. This is a -1/2 slope. Okay, so if I graph that out, that is the line y equals -1/2 x plus 4. I'm going to put that's line F. Okay. Ooh, we want F that's going to be parallel to it. So let's just go ahead and mark this as line let's say line X. My eraser's working lovely right now. All right, I'm gonna say line X. There we go. Okay, so now I need to graph one, write an equation that's parallel to that. Well, we said parallel has to have the same slope and different y-intercept. Maybe I'll leave it just like that. What's the y-intercept here when we have a y equals negative 1/2 x? Well, the y-intercept is 0. Positive 1, negative 2, positive 1, negative 2, positive 1, negative 2. This right here is going to be parallel to line X. Has the same slope, different y-intercept. Okay, so I'll label that as line F. Okay. Then it says write an equation for line G such that is perpendicular to the given line. So line G is perpendicular, so I need the opposite reciprocal slope. So if I do this, opposite reciprocal. Well, the opposite's going to be positive. The reciprocal of 1/2 is 2/1. So I'll just write it out like this and just say, hey, it doesn't matter what my y-intercept is on the perpendicular. So I'm going to leave it at 0. And so I'm going to do a 2/1 slope, 2/1, and down 2/1. I'm going to label that line G. Okay? So again, I'm hoping that that's making sense to you how we're doing that. Okay? Now, determine whether the following lines are parallel, perpendicular, or neither. Now, I will tell you this. You could go ahead and plug both of these into, all of these equations into Desmos and then count. You can count the rise and run if you can find 2 points that are on the line. Okay? However, I think it's a lot easier to go ahead and solve for y so that you know, exactly what the slope is going to be. Okay? So as I look at this, if I wanted to solve for y, what's the first thing I should do? Well, I'm thinking I want to subtract 2x from both sides. So if I do that, 6y equals negative 2x plus 12. Okay? Now how do I get y by itself? I'm going to go ahead and divide everything by 6. So this gives me a negative 2/6, which becomes 1/3. 12/6 is 2. And so as I look at this, I have the same slope, but a different y-intercept. So I'm going to say that these are parallel. Okay? For letter B, I'm going to do the exact same thing to solve for y. So the first step to solving for y in letter B is to go ahead and add 6x to both sides. Okay. Then from there, I'm going to go ahead and divide everything by 8. 6/8 becomes 3/4. 24/8 becomes 3. Now again, I notice I have the same slope and a different y-intercept. So this too is going to be parallel. Okay. To finish things off, letter C, I have a -7 slope and a +7 slope. Now, if you're not careful, you're going to get this wrong because they do have opposite slopes. One's positive, one's negative, but they're not the reciprocal. Okay. If I had my slope was 7, my perpendicular slope is going to end up being -1/7. Remember, this is over 1. Okay. So in this case, the slopes aren't the same, and they're also not the reciprocal, opposite reciprocal. So I'm going to put down that this is a neither. Isn't going to be parallel or perpendicular. Okay. All right. So you see the problems that you have down below. I want you to go ahead and complete those for me, and we will talk tomorrow about how you did. So thanks for listening. Good night.